Hey, hello, I'm Dave D. Hillstra, and you've reached the Saturday morning chats. Yes, good morning, good morning. This is a new format we're doing, which is more like interview and talking and not so much the prepared parts and just discussing things that are very interesting. And today, of course, we're going to be talking about the Webb Space Telescope and its images. And of course, all of us who are not proponents of the Big Bang do actually understand that these new telescopes that see further and further into the universe actually help our cause that the Big Bang is not a good theory. So we're going to be talking to really two great experts today. One is George S. Coyne. He is a Canadian, and he has written extensively about the Big Bang and the problems. And also another favorite scientist of mine, Dr. Glenn Borchardt, who is a science philosopher and a geologist. But his science philosophy books, in my opinion, along with George's books, are some of the seminal books of our generation in science. So, and by the way, if you do like this program, please click on the subscribe button down below and on the like button. Really helps us. Actually, the CMPS now has over 1,000 subscribers. That is great. Thank you so much for those who are subscribing to the CMPS, and also the Dissident Science channel. I think we're up to 4,300 or something like that. So I want to thank all of you. You guys are going to be in for a treat today. We're going to be looking at and talking with our experts on the Big Bang, and also looking at some articles and discussing that in a discussion format. So first of all, I'm going to bring up George Coyne. We got Dr. Glenn Borchardt in the green room too. He's getting his connections. And let me just tell you a little bit about George before we bring him up. He is an author, but George is a Canadian science communicator, philosopher, author, educator, and counselor. He is a unique writer on the theoretical physics, consciousness research, and cosmology. He was born in Toronto, in Ontario, and he moved to British Columbia. He then got deep interest in the area of physics and cosmology since he was quite young, and was fascinated by topics, and wrote a book called The Not-Finity Process. And I thought that it took me a while to understand what that meant, but what I really, I mean, I read his book cover to cover, and I've interviewed him about the book, but it actually took me a while to really let it sink in what not-finity is, meaning infinity as we know. I believe in an infinite universe, infinite time, infinite space, and of course, so does Glenn Borchardt. We all agree on that. But the idea of infinity gets to be a little tricky, because it seems like some infinity seems bigger than other ones. But that's not the important part of it. But what I liked about the not-finity process, it's that there is no such thing as finity. There is infinity, as much as that can take us some time to understand, or maybe we'll never understand it fully, but there's certainly not affinity around, and I highly recommend his book. So without further ado, I'm going to be bringing up George Coyne. How are you, George? Oh, you're muted. Okay.
There, is that better?
Oh yeah, absolutely.
Okay.
Having you talk. So why don't you? I know you have kind of prepared an introduction to this, but I want to first thank you. It's 7 o'clock in the morning there in Canada, isn't it?
That's right.
Yeah, and so people are watching. I know that Ian's watching from Ireland, and he is a little ahead of time. So we're spanning the globe here. So quite a few meridians off from each other. But I appreciate you getting up in the morning. Once you said you have a little introduction
Yeah, and
talking about
before we
that.
start, just you mentioned my book. It's has a reduction. It's down to 23.75 US right now, 30.95 Canadian for 408 pages.
Yeah, no, that's a really great price.
It's like half price from what it originally was at.
Yeah, absolutely. So check that out. It is a great book, especially if you want two things it talks a lot about is consciousness, which people talk about incessantly. I'm a computer programmer. I love George's book. When I first met him and he started talking about it, oh no, another guy in consciousness. And then I go, whoa, this guy's saying great stuff. And that's how we met. I was introduced by Duncan Shaw, who's in this picture down here, as you can see down here, in one of the pictures, standing next to. And I'm glad he introduced me to you. But yeah, you need to check out the Not for Any process. Talks about two things again: the consciousness, what that is, and the Big Bang. So yep, check out his book for sure.
Okay.
All right.
So anyways, just to give a quick introduction to what this James Webb has been revealing. Before the images produced by the James Webb Space Telescope, shortened to JWST, the most distant galaxy ever found was GN 711 with a redshift of 20, as it appeared about 420 million years ago after the hypothesized Big Bang. The JWST has recently discovered dozens of the furthest out galaxies dating back to about 200 million years after the Big Bang. Commenting on recently discovered distant galaxies found by the JWST, an article published July 27th, 2022 at space.com with the title James Webb Space Telescope Beats Its Own Record with Potential Most Distant Galaxies from Space. And it states, quote, "These galaxies span only 1,000 or so light years across and contain just tens of millions of stars. Modern galaxies can host hundreds of billions of stars. Astronomers estimate that the cosmic babies are less than 100 million years old and possibly as young as 20 million years." End quote. Yes, the article did state 20 million years. That's a blink after the supposed Big Bang. The existence of these galaxies so close to the imagined Big Bang contradicts its theorists, who had previously claimed that the first galaxies took 1 billion years to form. An article published July 20th, 2022, titled JWST has found and captured the oldest galaxy we have ever seen in the universe, makes truly amazing statements. The writer states, quote, "The telescope JWST has broken the record for discovering the oldest galaxy so far, about almost 100 million years after the Big Bang," end quote. The article later states, quote, "These two galaxies have equivalent mass of about 1 billion suns in this time. That is very unique feature only thought to have in galaxies up to 500 million years old," concludes the team. "This might be a hint that the stars usually formed more rapidly than we believed in the early universe," end quote. That's unbelievable. They're changing how quick stars form. Unbelievable. Rather than come to the obvious logical conclusion that this indicates that the universe must be far older than the 13.787 billion years claimed by Big Bang theorists, astronomers prefer to alter the established science of how rapidly stars form. If the JWST finds fully developed galaxies that are 100 years after the Big Bang, will its theorists then claim that the stars arose simultaneously with the Big Bang and immediately formed into the galaxies as seen by the JWST? Based on the requirements of the Big Bang theory, the supporters of it are stuck with an absolute limit of 13.8 billion years for the age of the universe, which means they cannot arbitrarily increase its age, especially not by 1 billion years to accommodate these fully formed galaxies, which are only 20 million years after the supposed Big Bang occurred. Because these newly discovered, fully formed galaxies do not conform to the Big Bang model, and there is no way to account for their age, it is rational to view the Big Bang model as falsified. And that's the main end of the introduction.
Yeah, I mean, I think one of the problems is that you have this dichotomy, right? You want to look further into space. You want to look, all of us are fascinated by the images, right? I mean, we're all fascinated by those images. And so the moment they look further out into space, the older the universe gets. In fact, I think, wasn't it in the beginning of the 20th century, they thought the universe was millions of years old, and then it went to a half a billion years?
Well, before the early 20th century, they didn't even know there was anything beyond the Milky Way galaxy. That was the entire universe as far as astronomers were concerned. They didn't see and didn't know there was anything, any galaxies other than the Milky Way.
Yeah, and then it seems like as we look further and further into space, we had to keep changing how old the universe was.
Yeah, well, what the thing is now, though, they are stuck with the model that it cannot be more than 13.8 billion years maximum. And Glenn will talk about that. He wrote a recent blog on that. They're absolutely stuck with that date. If it goes beyond that, then it throws out the whole.
So what is that? Why are they saying it's only 13 point something?
Well, I'll leave that for Glenn because he's got a good article on that. When you
Okay, yeah, we have we're still trying to get Glenn connected here, I think.
Yeah, but the article he wrote recently in the on his blog, he explains you cannot have it, and because I was originally thinking that maybe they could simply say, well, the universe started out 15 billion years ago, and he proves if you do it, then the whole Big Bang theory goes up. And I think, is that the article there where he says?
No, it's not that article, but this is with his blog. Oh, here he is. Oh my goodness.
He can talk. Why don't you go to him now and he can tell.
Well, yeah, there he is.
Yeah,
well,
can you hear me okay?
Absolutely, Glenn.
Glenn.
Great to see you.
Yeah. Well, that blog is on Medium.com as well. I just also am publishing on Medium, which has got a possibility of getting writers paid. I'm trying to develop a foundation for a progressive science institute that continues after my expiration date, which is obviously coming up. My hair is not turning any browner or anything.
Yeah.
Anyway, so what has happened is that the calculation got stuck at 13.8, as I understand it, when the Z numbers, that is the cosmological redshift numbers, got so great that is over 1.5, so great that the recession of the galaxies, which was part of the theory, was supposed to be greater than the speed of light. Now, Einstein is the basis of the Big Bang theory, and you can't contradict Einstein. So that was a real problem. And so that was solved by actually confining the age to 13.8. And now you see the big contradiction showing up that George has pointed out, and you have been mentioning too all along, is that these so-called elderly galaxies are showing up in the Webb pictures at over 13 billion light years away. And so that's the problem. And so what are they going to do about it? Well, they're stuck. They have to either change 13.8 and give up Einstein's C, and they're not about to do that. And so you can see in the blog that I gave on it, there's all kinds of ways you can calculate the ages of the universe. The universe, of course, is infinite and eternal, and so they'll continue to see more and more stuff as our instruments get better. Now, whether they get better than this infrared measurements and so on, I'm kind of doubtful, but remember the microwave background that's talked about so much is a Z value of 1089. I didn't realize that until I just read that the other day. So what that means is that the infinite universe has been sending light everywhere, of course, and it shows up in the microwave background. I'm not even sure whether that's instrumentally correct, but that's what it comes down to. Yeah, this is neat that you pulled this up. You can see this. I don't know if you see my little arrow there, but here's how you limit the thing to 13.8, and you can get all kinds of numbers here if you want to see the velocities given here are greater than c, and of course nothing goes faster than c, and even if you think light's a particle, it doesn't go faster than that, and so that has been a real problem. And these calculations you see is all kinds of different, these values here, these omega values, are how much you think the universe might be curved. And you know, with Einstein's space-time, it's all kind of wrapped up in a finite ball, and it's either negative, which is a saddle, or it's actually a round ball. Like the plus values for these omega numbers, and you can put those in if you're a believer in general relativity. If you're not, you can skip all these. But on this blog, you have links to how to do some of these calculations, just from a website that I found, and it's really instructive. You can see these redshifts can go over 10, and of course we're beyond, like George was saying, maybe 20, and what's been confirmed is that certainly 11 and 13. So those are values here, and they're all going to flatten out, and they're not going to change the age of the universe according to their theory. It'll still be 13.8, and that's where they're stuck. And you're going to pretty soon have 0 ages for some of these elderly galaxies. And I like to call them elderly because, you know, the Milky Way is 13.61 billion years old, according to
what really is amazing, and I was always wondering, when you look at Wikipedia and it says the date, the age of the universe, it's changing constantly. It goes from 13.78 to 13.81.
Right.
It's just absurd. The other thing I don't understand in general, and I think maybe a lot of people don't, is if you are looking back in time, how is it that this light is taking so long to get to us, right? So those things that we're seeing were that of that age then, right?
Exactly.
And so if we keep going further and further and seeing further and further, and we can continue to see galaxies that look like the galaxies next to us, I can't understand why, you know, who's going to break that silence and say, look, folks, this isn't making any sense at all.
Don't hold your breath on that one, because we've had these elderly galaxies, and that's what I call them. You get spiral galaxies over 13 billion light years away. So that's been going on since 2009. As I pointed out in that blog, we've been mentioning elderly galaxies. Each time it gets younger and younger. And some were 500 million, now 400 million, now 300 million, and then 225 million. And before you know it, it's 0 million. And what are you going to do then? So that's the problem with what they're faced with. And here's that's a neat one, because what they assume, what Hubble first assumed, was that the galaxies were all going away from him. Now, he was only looking at nearby galaxies, and many of them were going away. Some were coming to us, of course, like Andromeda. But this is what he plotted. The distance and recessional velocity were related, according to him. And then later on, we finally realized that, well, it's just a distance effect. Everything that goes from point A to point B has to lose energy. You can't have a particle, like if you throw a baseball, what happens to the particle? The baseball has a reduced velocity, right? Well, we don't have that with light. Light doesn't do that. Light's velocity is controlled by the medium, and so what has happened then is that if you go to that, if you drop down to the next one on that, here's where I just slip in Z number and distance, and that's what I think has happened. So the larger the Z number, that's the cosmological redshift, then the greater the distance. And here it would show it as a straight line function, which is what Hubble thought. And so it's ironic that Hubble was used to name the first space telescope, and then that he was considered the fellow who discovered the expanding universe, which he denied. He denied it many, many times.
He denied
And
what? I'm sorry. What?
and
The bending
these,
of the.
yeah, and the regressives didn't want that, and so they just ignored it.
So are you saying he denied the bending of the universe? What did you say?
The expanding.
The expanding, right?
That he had discovered an expanding universe. He was like, he just thought there was some reason for the redshift other than recession of galaxies. In other words, galaxies going away. It always had to do with the fact that a particle or a wave cannot go from point A to point B without losing energy.
Of course, of course.
And that's what we're seeing as you get shorter, yes. I mean, longer wavelengths. The longer wavelengths are going to be having less energy, right? And then that's just the law. So that's what it's telling us. You're losing energy over distance. That's all that's happening. How that's happening, we don't really know, but obviously it has to be happening. Now, one of the problems, the reason they can't come up with that is that all of the Big Bang is based on Einstein's special relativity and general relativity. And what Einstein hypothesized by denying ether, he said that essentially that there was perfectly empty space. Perfectly empty space is imaginary. That's part of the continuum between space and solid matter. Solid matter is imaginary. Everything we know, like hydrogen, for example, is part empty space and part matter. And that just goes on infinitely for particles. And so because he did that, that meant that light could travel as a massless particle filled with perfectly empty space, traveling perpetually through perfectly empty space. And that's what the Big Bang is based on. And that's how you get expansion, because they don't recognize any loss of energy over distance.
Right.
They can't.
That's really absurd.
If your particle, your massless particle, is traveling through perfectly empty space, there is no reason for it to slow down.
Right.
Okay. And that's the critical issue right there.
Yeah, and it's funny because when I'll let you go, George. Just hold on to that thought. When I was growing up, I loved the space. I was one of those kids who grew up in the 60s and 70s, and I followed space. You know, the Apollo moonshots. I loved that. I used to make models and everything. And when I was young, I had this idea when the Voyager craft went out into the into the solar system, that once you were kind of out in space, it was empty. And then in my mind, I still have that model that's really burned into my brain, that when you send this probe out, it's going to keep at the same velocity and go in that direction forever. In fact, when we hear people talk about it, scientists talk about it, they're going to say, well, when is it going to stop? Nope, it's going to go at that speed forever. And yet we have the Pioneer slowdown, right? And that was one of the things that I always had stuck in my brain. And now I realize you can't, this is a Newtonian universe we live in, and you can't go anywhere without having some type of effect. It's not going to go forever like that. You were going to make a point, George?
Yeah, just I'm very amazed when we know that Hubble did not accept the idea of the expanding universe, and yet conventional orthodox astronomers do. Yet they've gone and they've named the telescope the Hubble after him, so he must be well respected. How do they make how do they hold these two opposing thoughts? Like, we don't agree with him, but we're going to name our telescope after him.
Those are that's a major contradiction, and there are dozens of contradictions. I think you pointed out how many of them, 50 or 60 for the Big Bang?
60.
Yeah,
you had over 60, George, right, in your book.
Yeah.
Reasons.
64. Yeah, I came up with 64 in this book. 64 major problems with the Big Bang theory.
Well, I would believe your argument more if you could come up with at least 65. For me,
this is 65 now.
I'm sorry. I mean, I was reading and I was waiting for that 65th one, and I just said,
it'll be in the next. Now that we've got these pictures from the JWST, I'll have to say, well, here's the 65th, is that they've got galaxies now that they believe might be as close as 20 20 million years after the Big Bang.
Yeah. No,
Yeah,
it's
I can't keep this book updated fast enough because they keep coming up with new things that are totally falsifying the Big Bang. This is the most incredible, though. These pictures.
yeah, no, I mean the pictures we're going to see, more and more. But this reminds me when I went to the first MPA conference that I went to back in 1996. It was being held in Flagstaff, Arizona, and there they have a telescope. I can't remember the name now. It's getting old now, but in Flagstaff, Arizona, and that's where Lowell, the Lowell Observatory.
That's right.
And yeah, and that I think that's where the Big Bang kind of was started. I think that's the origin there. But regardless, I happened to walk in, and it was 1996, and in just a couple years earlier, I saw a photograph that was in their auditorium because they had a presentation auditorium there, and of course, it had a lot to do Big Bang, and they had two pictures on the wall, and it was the picture of what we saw with telescopes, which was deep space, which was blackness, right? There was a picture, and then there was a black spot with nothing in it. And then right next to it, it showed the Hubble telescope and what they saw in it, which was thousands of galaxies. And at that point, I was thinking, this is just going to happen again. We're going to have another telescope out there. We're going to go into a place where we're not supposed to see anything, and we're going to see lots of stuff once again. So, I mean, that kind of repeating is going over and over and over again.
Yeah, we haven't been able to find any perfectly empty space. Remember when the James Webb went up, we figured, well, okay, there's different possibilities. One is we're going to see perfectly empty space. Okay, some people dreamt of that. Or we would see only stars, no galaxies, no elderly galaxies, only stars, which would indicate, well, there you saw the beginning of the Big Bang. And guess what? We didn't see any of that. And as you mentioned, perfectly empty space, the vacuum, we've never been able to produce a perfect vacuum. We can get close, but there's always something there. And we've proven that it's not just in the galaxy, but apparently outside the galaxy, that we have evidence that it's not perfectly empty space. And you need perfectly empty space for Einstein's theory to work. And it just doesn't. And you can't get expansion that way. So that's the problem. And remember, Einstein's like a god. And if you're going to be able to change a paradigm, what's going to happen? Einstein is going to fade away. He's going to say he's just another joker we had around. But people believed it. And of course, if you look at my book, Religious Roots of Relativity, basically, all his stuff is based on religious assumptions. Perfectly empty space is one of those. Remember, if you're going to be a creationist, you got to start out with nothing, perfectly empty space. And that's what Einstein hypothesized when he gave up the ether. And there might be other things other than ether, of course, but he gave up all particles that would interfere with his magical massless particle. There's no such thing as a massless particle. Yeah. It's not possible. But that's what it is. And so and this caught on with religious folks a lot, because remember, if you're going to have a creation, you're going to have it from nothing. They talk about singularities and all kinds of silly stuff, but they got to have perfectly empty space in order for it to work. That's what creation is. So what you see as the Big Bang Theory is the last gasp of creationism.
Now, wasn't it the Pope at one time? I think I remember where one of the popes said, "Now we embrace the Big Bang."
That's right. It's right, and it should be, because it is the last creationist theory, and it's so firmly established among most people are religious, right? So 80 to 90% of the world's religious, so they're going to go for it, and that's why we have Einstein, the Big Bang, and all these contradictions. The 64, and maybe if you keep digging, George, you'll get 65, and Dave will be happy. And,
well, the other thing though too is it's interesting because when we talk about the religious aspect, and I respect people who are religious, that's cool, but I was thinking, this whole idea that it's eternal, that God's eternal, he's been around. I don't see. I know the religion, you can look at it philosophically, but I can see easily that if the Big Bang finally is accepted not true, that if you're a religious person, yeah, the universe has been around forever, God's been there forever. That kind of goes together. I mean, there's obviously there's faith there. There's things that are somewhat magical, of course, but I think this idea that it can't be, I think maybe part of it is, well, what if we get rid of the Big Bang and creation didn't happen? That kind of proves God doesn't exist. Again, I'm not talking about that. What I'm saying is it's not mutually exclusive because they didn't believe in the Big Bang in the first place. But I think there's also the problem with the Einstein is I'm one to torture myself constantly with Einstein's Facebook page. If you go there, there's almost 20 million people. We actually had on Facebook, on Einstein's Facebook page with 20 million followers, there was one person posted from the CMPS or the MPA, posted on by the keepers of the Facebook page, which I know are actually, I did some investigation. They are linked to the university in Israel, who was making $12 million a year on his image. But that's another story. But they actually posted something from Dr. Edward Dowdy, who said that, outside of coronas of the sun, you don't have any bending of light. And so he challenged general relativity. And I remember very clearly that it was posted like, hey, this guy from NASA says that general relativity is wrong. And it was almost like the people who owned the page were trying to go out there and say, okay, all you people who believe in relativity, come at this guy. And they did. And I would say about 3 or 4 years ago, since I've been on that page, what I do is I don't ever go to name calling. I'm always talking logic. I'm always talking that there, as Glenn Borchardt has said, I think that was the first time I heard it, someone say that relativity is the most disputed theory on the planet. A couple of years ago, when I would make any comments, and the reason I would is I can get people, and I noticed that when I posted, we would get more subscribers, or we would get people subscribing to a newsletter, etc. So I felt people are reading. If you got 20 million people, they're going to read the comments. So I'll put them on there for those people who also have a doubt about relativity. In the beginning, I would put it out there. No one would give it a thumbs up, of course, because they all worship Einstein. And I get these 3 or 4 people who I know very intimately. They all have fictitious names. I know they're fictitious. That they'll put laughing things, and then they put a link to me on some crackpot page or whatever what they already do. Recently, I've been on there now for a number of years. I'm a top fan, so that means I'm there. They haven't kicked me off. I don't know why. The other thing, now, when I mention something like about the Big Bang is wrong, and I say it in a very teaching way, I want to say it so that people who are critical thinkers will, now the 3 yahoos that go on there and put the laugh at me, because of course, when they can't argue against you, they smear and laugh. That's why you're right. But now the thumbs up are winning. And it seems like people are more and more, willing to maybe give up on this Einstein. But, that's part of the problem. The problem with Einstein as well is that he was, in 2010, he was the second most profitable dead celebrity behind something like Elvis or something like that. He was making $10 to $12 million a year for this university in Israel. And now they've linked up to the web page, and believe me, they're not going to let go of this thing, because having 20 million followers on Facebook, that translates literally into money into their banks. But it's amazing. I'm starting to see a shift where when I used to try to make very solid arguments and point them to articles, we have a page on Beyond Mainstream where we have over 2,000 papers and books who show Einstein wrong. That it seems like it's starting to crack a little bit. So I'm really hoping that that's going to be the case. So anyways, somebody in the green room, we have James Keene. If you want to join us, we do have people in the chat, of course, but let me put that up there. So if you do want to join us, you can come in and talk with us live. We do have people in the green room, and if you would like to come up and make a comment or join the discussion, you can. You can go to live.naturalphilosophy.org, and you can come into the green room. I can bring you up, and you can come and argue against it. I do see some interesting questions, but I do want to leave. So if you are in the green room, would like to come up and make a comment, raise your hand or wave at us. Or if you're just going to sit there and squirm in your seat, hoping I won't put you up there. I may just do that on purpose. Oh, there we go. Of course. One of my favorite cantankerous people, and I do admire him quite a bit. He's a great writer. If you haven't read any of his works, he is an excellent writer. You can go to beyond mainstream.org and read some of his articles. So welcome aboard, and hello, Harry.
Hey, good morning. The limit that you're talking about of 13.8 is based on quasars. Is that correct? Did you make that statement? Not correct?
This is in the blog that I showed. What to base it on, I don't know. It's redshifts, and one reason you might use quasars is you can get them inside the galaxy, and so you can get some ages that way. But
that's what I thought was said. So I guess that's my understanding of that was incorrect. Well, this gets to my point, which is that this is the age of the universe is based on the slope of the Hubble law, and the Hubble law has been changed. I think somebody alluded to that.
Right.
I don't know who. And it's gone from, it's moved around every time, I don't know what the number is today, but I think it's 70, 60 something. I forget.
It's about 70.
Anyway, 70. Okay.
Yeah.
And I remember it was 100, then it was 50. And then, they did this compromise. Oh, it's 75 and now it's 70. So, okay. Yeah. So the age of the universe has changed quite a bit. Okay, but it's all based on this redshift, redshift. Now, a couple of things about that is that was a hypothesis that goes back to when they first, around 1900, they noticed that there was a spectral shift in galaxies, and Slipper was the most prominent researcher, and they interpreted that as a velocity. So the astronomers, basically because they can measure velocity by measuring shift in spectral lines, that was their main tool of analysis. And so that was the assumption they made, that the redshift was a velocity. The cause of the redshift.
Critical error. Yeah, critical error.
Okay, now we know that Chip Arp is a big critic of that. There are a number of critics of the idea that the redshift represents a velocity, okay? And that's not really been accepted. And I think the reason is that really kind of messes up the beautiful theory that they've created from Einstein. And what I think about the Big Bang and what you have to realize about Einstein's theory is that they can explain the creation of the universe from a very simple differential equation. Okay, so scientists come forth and they say, we can explain the origin of the universe against religion by saying, we, the scientists, can explain it, and religion can't. So they're claiming to be superior to religion as far as explaining the existence of how we got here. Is that not correct?
That's right. And of course, remember, these guys probably are atheists, but they have been religious in the past, and they use some of their early assumptions, like everything has a beginning, right? Well, you can't have a beginning for something if there isn't something outside of it from which you can make it, right? And that's why you need to have an infinite universe. It doesn't work any other way. You can't have a finite universe. That's not going to work. So anyway, they're using and as I pointed out in my last book, it shows that they're using these assumptions, and that's why it's so popular. If you write a religious book, you're going to sell 1,000, maybe 10,000 times as many copies as you would just a regular science book, which doesn't help.
Okay. I agree, Glenn. Lemaitre is responsible, I think, for this because he really is the origin. You know, he had this cosmic egg theory, and he was a Jesuit, as I recall.
Yeah, yeah.
And so this whole Big Bang theory originates in religion. So there's a certain amount of religious in it, but it also allows scientists to explain the universe from a differential equation, which makes it a mathematical explanation.
Yeah.
And a differential equation has an arbitrary t equals 0. Am I not incorrect on that?
The whole problem is not, you see, there's a lot of math that's been used around the Big Bang theory using the initial assumptions. But if the initial assumptions are wrong, well, then of course the whole math is wrong too. And that's why I've got into philosophy, scientific philosophy, where I said, look at what's going on. You can change any of these equations all you want, but the basic fundamental assumptions are what make the difference. And everybody has to understand. That's why you should read the 10 Assumptions of Science. And if you don't like the pay some money for it, I've got it on the internet. It's free as a PDF. So go for it and learn those assumptions, memorize them. And you'll find that they contradict, there you go, they contradict essentially Einstein and the Big Bang.
Glenn?
Yeah.
What do you think of Sir Roger Penrose coming up with this idea of a cyclical Big Bangs, where he's trying to get away from the idea that there was a beginning, and that we've got just that we're living in a Big Bang, and then eventually another the universe will expand, and it's very unusual sort of idea, and it's been criticized by in several areas. But he's got the idea that we're getting like this repetition of Big Bangs over and over.
Right, and so that's like the multiverse theory, the parallel theory, the steady state theory. They're all assuming expansion. Remember,
that's right.
That's what they're assuming. If you get rid of expansion and adopt infinity, then that's all gone.
That's the key
That's
point.
why I like the infinity assumption, because it solves so many problems. One example is this. You know about the second law of thermodynamics. Any isolated body eventually runs down, right? Entropy increases. Okay, there's a complement to that. In the infinite universe, there always is something else. So what happens to this stuff and in this isolated body is it goes somewhere else. And then where does it go over there? What does it do there? It creates something else. So that's the complement to the second, but you can't do that with a finite universe. And the finite universe is an isolated body. And so then they talk about heat death of the universe and so on, which is total nonsense. And remember, my philosophy is univironmental determinism. I had to invent a new word. Univironment means the thing and what is outside of it. So what happens to a thing, like you, for example, depends on what's inside of you and what's outside of you. When you're driving down the road and that car comes at your bumper, you're not necessarily going to be able to decide everything. So that's what happens to every single portion of the universe. Its motion is determined by the inside of it and the outside of it. Both are infinite. So that's why we have this very complex, that's why we have plus or minuses. Plus or minuses are telling us something. They're telling us that the universe is infinite and that causality is also infinite. There aren't a finite number of causes like Newton said, and like the old determinist said. There are an infinite number of causes. That's why you get a different result every time.
Well, I'd like to point out that for the cyclical universe that you were talking about, that is amenable to a math model. So in other words, you can create a differential equation. Again, it's the differential equation. They have to have a mathematical model. Okay, that's the key thing. You're doing science, you have to have a mathematical model. And basically, if you take away the Big Bang, they don't have a mathematical model. That's the problem they have. So they have this problem of we have to make our mathematical model work. Okay, and so you have to have assumptions that kind of fit into the mathematical model. If your assumptions don't fit in to a mathematical model, then you're not talking science. And I think that that's really fundamentally what the problem is. The issue that you're talking about today has to do with the fact that they've got a calculation, a model, a math model that says the universe is so old, and this is the number that gives us the age of it, you know, which to me is kind of silly to begin with, that they actually think they're so smart that they can tell us when the birth of the universe was. And now if that model is wrong, that basic calculation of the age is wrong, then their problem is solved.
That's right.
Yeah, one of the problems with all of the current modifications, that what I call reformists, they're saying, all right, we're still going to accept expansion, and Einstein and so on, but we're going to try to come up with something different. That's what the multiverse thing, they'll probably use the multiverse theory in order to explain these elderly galaxies. Because these galaxies are also going to have heavy metals, which are only going to form over a long time, not 20 million years, certainly. And, you know, they don't even form in the sun, which is 4.6 billion years old. So anyway, that's what's going to happen. And so now one of the problems with this whole idea of the Big Bang Theory is that the causality says object A collides with object B. That's Newton's second law. That applies to everything. So how does this universe pop out of nothing? What is the cause of it? Why would you have a cycle of something that doesn't have a cause in the first place? It doesn't make any sense. And it has to have
well, you need a math model to explain it for it to be science. So
yeah, well, maybe so, but you can't do that with infinite. Infinite is not going to do very much for that, but it does explain a lot of stuff. Just read my book, Infinite Universe Theory, and you'll find out what you can learn by it, using infinite as the assumption. And remember, it's only an assumption. You're never going to prove the universe is infinite or finite. You can't do that. But right now, they're assuming it's finite.
Let me make
They don't talk about it. Anybody they're cosmogonists. They're not cosmologists. Cosmologists study the stars and so on, the galaxies. Cosmogonists study the beginning of the universe. And if you assume there's a beginning of the universe, you can be a cosmogonist, is what I call these fellows. You guys are calling them Big Bangers, and I think cosmogonist is maybe a little more scientific. So I use that. But cosmogonists are those who start with, with the assumption that there was a beginning, and there wasn't. And this dark energy thing, energy is a calculation. So dark energy that they think caused the Big Bang, that's BS. That's not possible.
Well, I have two issues.
Energy doesn't exist. Energy is a calculation. It's like momentum.
I have two issues here to bring up for discussion. One is, do you consider the old steady state theory viable in view of the results that they've come up with?
No.
Nobody's really wanting to go back to the infinite age steady state universe?
No, because it's an expanding universe. He has to create a hydrogen every once in a while. I forget, every so many billion years or something. I don't know.
Well, that resolves the problem of the ages of the galaxies, because in the steady state theory, the universe is infinitely old, as I understand it. Not correct?
Well, yeah, but it's expanding theory, so that's why I call it reformist and inadequate.
Are you saying?
Okay,
Glenn,
well, so you're not in the least bit interested in rethinking that idea?
No.
Okay.
So sorry. Because I dumped expansion. No. I dumped Einstein. I dumped expansion and the Big Bang. So what do I have left? Infinite universe theory.
But are you? I'm not.
Read my book, Harry. You've got to read it and get me some comments on it. Because I don't know everything, and there's obviously going to be some mistakes that I need to correct.
Are there steady state? Are you saying that has as expansion as a part of it?
Oh yeah, right.
Oh, the steady state theory hypothesizes that there is a matter created. Okay, that there's a continuous creation of matter,
Right.
That and that this process is going on, and it's been going on for infinite period of time. So it doesn't have an origin in time. It's an infinitely old universe.
Wow.
And in that theory, you would be able to see galaxies that are essentially very old, okay, that are very distant, which would be consistent with the recent evidence, and that galaxies and that matter is being created in the present. Okay, so we should be able to see matter creation processes in galaxies in the present. Okay, but the supposedly the Big Bang, the microwave background radiation essentially killed that and led them to favor the Big Bang explanation. But I think the Big Bang explanation has sort of run out of steam.
So somebody here in the comments is saying Eric Lerner has a static universe theory. He suggests the universe is infinite. Now, in Glenn, when I'm thinking about the universe, one of the things when I talk about with the average Joe, who really is just not a science person, and they go, and I say, yeah, the Big Bang, that just doesn't make any sense. And they go, well, what do you mean? I said, well, in school, didn't you learn how stars were born? Yeah. Didn't you learn how stars were die? It seems like there's a cycle going on, that things have cycles. Is that something in the infinite universe that these things are going through, and all we're really seeing isn't evidence of a Big Bang, meaning this one is younger and this one's older. It's really, we're just seeing, life cycles in different states.
That's true for every portion of the universe. Every portion of the universe that you can see is a product of things from elsewhere. And everything comes in by convergence, and then it dies by divergence. That's what we are born through convergence, and we die. I've lost some hair and fixed some teeth and so on. And I am now on a process of diverging into the universe. So this is what happens to every single thing in the universe. There's a cycle, right? So you get galactic cycles. You form these stars. They are gathered together. They're pushed together as a galaxy, and then they are pushed further and further towards the center, the nucleus of the galaxy, and they're swallowed up by these big black holes, which are not really holes. They're just that. And so then an interesting thing, I had one blog question. Somebody says, once these black holes are formed, they just going to run around the universe naked. Yeah, that's true. And there's finding evidence for that now. And that they'll live forever, right? Nothing lives forever. And one of the things about black holes, or whatever they are, is that they dissipate. That is, they diverge over time, very slowly, of course, but they do. And that's why the universe isn't one solid black hole. Is not going to happen, because everything comes together and everything goes apart. And it's kind of interesting. It's sort of like Newton's first law. A body travels, until it hits something, or actually, he said, unless it hits something or something hits it. That's his first law. And actually, that's what we're seeing in every little thing. What happens is that a body and the constituents it's made up just part somewhere for a while, but it continues into the infinite universe thereafter. And that's what we see with ourselves and with everything in the universe too. But we don't need any expansion. The cycles go on. There's definitely a cycle to most everything. And so what else is new?
I think we lost Harry. Sometimes people are dropping out here, but yeah, I think one of the interesting points of the Big Bang in my mind is that it's such a house of cards. I mean, you try to really kind of grasp on anything. I mean, I guess what I'm trying to say is there seemed to be the idea of this explosion and everything coming out of it, and that seems like to be the assumption. And from that, I don't see almost anything logical that makes sense out of that assumption. I think it seems to be inherent. That assumption seems to have an inherent in it only things that are illogical, that don't make sense. I can't make sense of what we see and what that theory is, and so it's being propped up left and right by a lot of different things. Oh, I did put up here your universal cycle theory, which you wrote in 2011 with Stephen, right?
Yeah, Steve Pitts.
Steve Pitts. And that's where I really was introduced to neo-mechanics, and I went nuts. I remember calling you about that. And, when I saw the neo-mechanics and the infinite universe, I thought, oh my gosh, that's it. And so if you haven't checked out, if you want to look at another great book that is Glenn is co-author, I'd definitely check that out. It's a great book. So, all right. Do we have anybody else here that has joined? I see there's Steve Bryant, Nick. Ian Coyne. All right. The guy. The only thing I don't like about you, Ian, is that you have a very comfortable part of the day that you can attend. Whereas look at, Glenn and George are up at 7 a.m, and when we've talked to Dr. James Maxwell, he's about at midnight from Perth. So I'm hoping you're enjoying your day. But it used to be a nice temperature there, but I think it's a little hot there, isn't it? Been recently?
Yes, it's roasting hot to us. I think you'd find it a little chilly, perhaps.
Ian,
So
how you doing? I was wondering, are you ever going to drink that vine behind you there?
The vine. You're used to my geography here and so on. No, I thought I'd like to come in because I know David would ask me sooner or later, I'm sure, and it's most fascinating. Maybe a couple of points. And by the way, if you're somewhat jealous of my time, I would just say, well, you should all emigrate to the Cinderella zone. So just a couple of things. One was just a point about the steady state theory, which Harry asked Glenn about. But I think you were really talking about Hubble, not Hubble, Fred Hoyle and Bondi's, provisional theory of the steady state with continuous creation and expansion, as you say. But I mean, generally, steady state, not limiting it to that way, is quite possibly the alternative accepted theory. I mean, I would think, I agree with you actually that I work as a hypothesis that the universe is infinite and eternal, and I take it to be generally steady state. Now, not in the expansionary sense, but I also, you could wish to come back to that. I also wanted to make a point about the whole concept of this, and you can speculate, as we did a little at the beginning, as to why this Big Bang theory was accepted. There may be factors that scientists who'd been brought up in the religious environment but subsequently rejected it, were sort of hankering back to some childhood views of creation or something. It's also a most newsworthy exposition to show to the public and to make cosmologists and cosmogonists, as you call them, look very clever and newsworthy type people and attract people to their ideas. But whatever the philosophical or sociological reasons for accepting it, we have it now. Despite people like Hubble, as was intimated, sort of saying, well, look, one could look at a Doppler explanation, but, personally, he didn't seem to adopt that. But now they're saying that Hubble originated all this. So, and they're also actually attributing, to my mind, even more of a sort of an etiology to relativity, to Einstein's ideas than would be warranted, because it's nice to say, oh, it fits in with Einstein's ideas and so on. But anyway, for good or for ill, we're stuck with this now, and it's going to be very, very difficult to cut down. they're going to introduce ad hoc hypotheses to justify it and to save it. Dark energy was the major one that I think was referred to. I think that's the problem we face, and we've talked about this in regard to maybe some of the other established theories of 20th century physics, and this is certainly one of them. It's something that I think they're going to introduce hypotheses to save it, and in order to cut it down completely, you're going to have something more substantial than maybe some of the figures that you talked about. They start talking about, the early expansion of the universe is the reason that you can see things, orders of magnitude greater away in time than the universe is old, and so on. So I don't know what you think of those points there, gentlemen.
Well, you can guess what kind of ad hocs they're going to think of. One I mentioned was the multiverse thing. As if we're peeking into another universe that also expanded. That would be one ad hoc that I might think of, and I'm sure they will too. And there will be some ad hoc that will say the Big Bang, and I'm thinking the Big Bang has another 3 decades before it goes down. So
yeah, you had mentioned that.
Hold your breath.
But I remember, and that was a question I had. I'm glad you said that. You had a prediction. I remember early on reading your work on your books, there was a prediction by some kind of almost cycle or something. I don't know, was it in universal cycle theory? I can't remember, where you were saying more or less when this would happen.
Yeah, right.
The shift.
It's related to the sine curve for human population, and essentially the inflection point for human population growth was in 1989, and it's been declining ever since. And economics follows that as well. You can't sell houses to families that don't exist. So as long as the population is increasing, you can sell houses and make lots of money and so on. But this is going to decline in about the year 2050. It's going to be a severe drop in actual population growth. And I think at that time, and up to that time, there'll be a lot of strife. As you can see, we're seeing that currently, and that will happen. And we're going to have 30 years of grief. And then eventually it's going to change. And we're going to get a huge change in philosophy. And that's what will undermine the Big Bang Theory, because it's the fundamental assumptions that are what's wrong. Every paradigm there ever was destroyed because the underlying fundamental assumptions were wrong. And that's the case with the Big Bang. And so this paradigm, it has so many people, trillions of dollars are being spent on this, and so many people are getting employed as a result of Einstein and the Big Bang. You don't just drop that overnight. It takes a long time.
David, could I just make the point that with this Big Bang, it's had so many ad hocs. I've actually lost count how many ad hocs this theory has. When does the theory reach the point where there's so many ad hocs that you just say this is absurd?
Yeah, it's funny because one of the things my friend and I came up with a new technology for computer science, a programming language to writing intelligent programs. It was about 20 years ago. And I couldn't figure out why, when we launched it, no one cared about it. And so I watched some TED conferences, right? And what makes something be accepted? And he had a list of them, and he looked at lots of stuff. And this was in technology, but I think it can happen the same with science. He said timing. It has to be at the right time. You can have the ideas, and you can have the criticisms. How many people have had them, but it was not the right time to be accepted? And what I think Glenn is kind of alluding to is, well, he's trying to look at the human population and when these kinds of shifts happen. And I think, that's an interesting hypothesis. I think it's totally something that could actually happen in the sense of it's a valid hypothesis. I think the other thing too that I get involved in a lot with is language, because one of the things is we use language for intelligence and what we mean by certain words. And because I'm a linguist, I look at a lot of languages and what things, what words are there. And not all languages have it, but most of the languages will have a word for universe. And the idea for universe with that word, human beings, mean everything. And what happens is you get people taking a word and then what we call now science poetry, something we've talked about for the last 2 years. I didn't come up with that. So when you say multiverse, or there are more universes, or we live in a parallel universe, that undermines the assumption of what the word means. If you ask any human being who has that in their vocabulary, who's not like a big thinker, they're just, there's just a regular person, and you go up to them in the street, what's the universe mean? What's inside the universe? They're going to say everything. So this idea that, for instance, you have these brains, the Big Bang happens because there's these parallel brains and they touch and that sets off the Big Bang, for instance. Right. And people say there's parallel universes. We make poetry out of our vocabulary. Another one is dimensions, right? Time is a dimension. That's the fourth dimension. Whereas dimensions, are 3. That gives you a point in space. It kind of defines mathematically a place in space relative to something else. But we call it a dimension. So it seems that a lot of the problem too is in the vocabulary and what people mean. I even see people in our group, even in the chat, one person says a word and they have their own definition for that word. So I think even the definition of what those things are. Space, right? Isn't it the case that in the Big Bang, they say that the universe was like the size of the pea and it expands, and he says, well, where was that? And what's around it? Not universe? Where is that located? And I go, no, space and time expanded together.
That's the Big Bang theory, yeah.
And it's like, wait a minute. And that's why I even talk to people. I said, okay, the Big Bang. I said, okay, what's the Big Bang? And I'll ask them, oh yeah, everything like exploded. I said, yeah, about the size of the pea. You ever heard that? And I always ask the person, this is the average person. I go, so where's that pea located? They go, well, in the universe. Oh, wait a minute. I thought the universe came from the Big Bang. It's the size of the pea. How could you measure the size if you have nothing around it to measure? All of a sudden, their heads the cogs start spinning. You see smoke coming out of their ears, and they go, so what about that football team today? They're going to be playing out the chase the subject.
Well, when you do that, I can do that too. Math can say anything you want it to. You can say, all right, you have this expansion, and that's what Hawking and others did, and then they just use the math. And well, if it's expanding at such a rate, then it eventually becomes not a pea, but the pinhead. It's even smaller. Anyway, you can do what you want with that. And of course, anything beyond universe is one. That's what uni is all about. So it's an oxymoron to have a multiverse.
Yeah.
And so now they'll jump into that ad hoc, and it's been well accepted. If you look up infinite universe, you will see multiverse. You won't see my stuff. You'll see multiverse. If you put in infinite universe theory, then you'll see my stuff. But otherwise, no, because that multiverse and the infinite universe are the same. And so same thing with steady state theory, and that doesn't work either, because you're creating hydrogen out of nothing? Well, that's just a minor false statement about what is really happening. How do things come about? They come about from other things. You can't just get it out from nothing.
Yeah, it doesn't happen by itself. Okay, and thank you so much for stopping by. Appreciate it. I see some other people in the green room. Anybody else want to come up? I see Nick. Are you waving your hand? Okay, he is. He's waving. There he is, Nick Percival. Oh, you're on mute. Let's get you off mute here. One of my favorite people too. Nick, if you haven't checked out Nick it has his YouTube channel called In the Nick of Time. And if you want to know all about time and relativity, I would highly suggest you look at both our interviews with him and his presentations. So Nick, what about the Big Bang? You're going to come on here and say to us, you do believe in the Big Bang, and we're going to have some really decent arguments. Was that what I'm imagining?
You know me so well. Actually, I've always wanted to win the Nobel Prize, and is George. Hi, George. Good to see you
Hi,
again.
Nick. Good to see you.
And Ian talked about whenever there has been a disagreement with currently accepted theory and empirical data, people have won Nobel Prizes by coming up with mathematical inventions to bridge that gap between the currently accepted theory and the empirical data. For instance, in the Big Bang, you have the inflation theory, where the universe suddenly expands by 10 to the 35th and 10 to the minus 32nd. And there's no explanation of why it began or why it stopped. So, in that spirit, yes, I am going to rebut you people, because as Nick of Time, that's the name of my channel, I have come up with an invention that explains this apparent discord, and that is dark time. When you look back more than 13.6 billion, you get dark time, and you cannot draw any logical conclusions from those measurements.
I'm going to blame you. This is a moment in time, because if all of a sudden we start seeing PhDs writing about dark time, you have just thrown another stick into the spokes of progress in science. So that is hilarious. Go ahead.
Well, I'll make just some general comments. I think we're better off not saying that we've disproved the Big Bang, because you can always say, oh, what the Big Bang was really 26 billion or 52 billion years ago. I think what we've disproved is sort of Hubble's law about the redshift being totally a function of velocity. So I think we have to, as critical thinkers, I think we really need to be careful about what conclusions we jump to. I'm a religious person, but when my fellow religious people talk about Big Bang proving God or being consistent with the Bible, I just be careful what you hang your hat on, because I saw the Big Bang was going to blow up and explode and go away. So I think we I think that the Big Bang actually came from misinterpretation of the empirical data and a lack of critical thinking. So when you got Hubble's curve about the redshift, I think that's what led to the Big Bang, as well as general relativity. And we wouldn't have gone there had there been more critical thinking about exactly what we're saying, because Hubble came up. I mean, Harp came up. Hamilton Harp came up with a nice debunking of that paradigm. So
yeah, Hubble. Interesting that his very first paper, I think 29, he talks about the recession of galaxies. And so he is fitting in with at that time, he's fitting in with relativity and so on. And so, but the next four papers that I could find that Hubble wrote or was quoted in all talked about doubts about the expansion. So that's quite clear, but he made a big mistake. Now, Sagnac, however, didn't. Sagnac said he had proven the existence of the ether back in 1913. And so he was forthright. He just said it. And that's the kind of guy I am. I don't mess around trying to do politics with science or anything like that. I don't do Einsteinisms. Remember, in the dissident community, you know what Einsteinisms are? They're being right for the wrong reason. One example was what made Einstein famous. In 1919, Eddington did that experiment in which he looked at star light coming past the sun when it was an eclipse. So he could do it. And it was bent. And sure enough, space-time was curved. And Einstein was famous forevermore, the biggest genius. Okay, well, what was that? Well, that was simple refraction, is all that was, because the sun has a corona, and why wouldn't it be bent? And Dowdy covered this endlessly, right? So this is an Einsteinism, and this goes throughout all of those so-called proofs of Einstein. Other theories are not like that. In science, we assume, for example, evolution in biology. We assume plate tectonics in geology. We're not proving that every day or anything. In Einstein stuff, oh, well, gravitational waves, that means he was right. And we have these waves coming through perfectly empty space that's compressing and decompressing. Well, that really makes a lot of sense, doesn't it? And that's what the reporters will give you. They'll say, oh, yeah, all right. Instead of an ether that has actual matter in it, the universe consists of matter in motion everywhere, infinitely so. And that's where we're at. So Einsteinism is, and that's what we get all the time. We're always proving Einstein right. Why would we have to do that?
Yeah.
Two quick things. One, I'm driven by one Einstein saying. He was saying that all physics is local. And I think that's a pretty good guide for 99% of physics. The second thing you talked about the bending of light around the sun. So I have a question. I've seen a lot recently about so-called gravitational lensing, where light passes by galaxies and you see dual images of some star behind it. So is that a case of light bending? Quite frankly, I'm confused on that particular phenomenon.
Probably is. I don't know the details. It's there. It's empirical, right? So we
Yeah,
have
you see the distortions of the double images. So maybe that is light bending. But
well, it would be
it
bending
can't.
because of the atmosphere. Everything has an atmosphere, and the galaxies do too.
Yeah, this is the photograph people are referring to, because you can see supposedly these galaxies that look like they're reflecting that this is the star and that light is being bent. There's a couple explanations in my opinion. Number one, yeah, you can have lensing, of course, with refraction. Number two, you can also have things just like I think we're getting fooled sometimes. What Halton Arp did. Let's see here. If we just do gravitational lensing, I think there's a better photo here. Come on.
Oh.
There, this one here. Yeah, here we go. So you can kind of see these kind of like wispy things. Now, what they're trying to say there is this is the gravitation bending the light, and we're seeing galaxies behind it there. And we'll see, oh, that's a galaxy. Now, again, in my opinion, there's three explanations. One, yeah, gravity bends light. Number two, there's something there. Number three, we could be seeing what Halton Arp saw, which are optical illusions. Remember when they were trying or non-optical illusions, but what we're seeing either fools us into thinking it's something else, or what we're seeing just because of the position what we see. One of the things that was in my movie Einstein Wrong, the documentary with Dr. Ed Dowdy, he would say that if gravity truly bent light, we'd see Einstein rings all over the universe. We'd just see these very strong gravitational fields making rings because there's stuff behind it. So I really, this is when I saw this, I got actually a kind of a bad feeling in my stomach, because I'm thinking, oh no, this is going to be another. Oh, wait a minute, I'm not showing you this. I'm sorry. I'm looking at it and I got the wrong one showed. Okay, sorry folks, this is what I was looking at. My apologies. Everybody, George is looking around like, what the heck is he talking about? But I shared the tab so it looked a little nicer than sharing my whole screen, because I thought that would be great, and then it bites you on the behind. But yeah, this is the one where you see these kind of wispy things here, and you kind of look at it, and it kind of looks like this is kind of going around this, and this is kind of going around that, and you got one over here. Yeah, if you look in the universe, you're going to see all kinds of patterns, right? You're going to see a picture of Elvis, right? You're going to see whatever you want. But when I saw this, I really got a bad feeling in my stomach, like sick to my stomach. Oh no, here we go. They're just going to show, yep, this is Einstein rings. This is the light lensing again that predicted by Einstein, and I think it was on Einstein's Facebook page as well. So yeah, it comes down to what people see, and they're going to grasp. Again. We get back to the idea that you were talking about, Glenn, which is basically proof. There is no proof for anything. There's never proof for everything.
Just some confirmations. And
right.
In case of Einstein's calling, remember he said light was a massless particle. How in the heck can a massless particle be affected by gravity? It doesn't make any sense. So that's why the Eddington thing, there were two explanations for Eddington's thing. One was a bent space-time, and the other was the effect of gravity on light. Well, if you're going to assume that light is a massless particle, it doesn't get affected by gravitation. And that's just the fact. So what you're seeing in any of these things, these phenomena are simply refraction. When light goes past something, it's got to be refracted. Yeah. Why doesn't it? It has to be, because it's a wave, and that's what waves do. Yeah.
I think the other thing is too, it's kind of a little different topic, but one of the things about all this nonsense, all of this paradoxical stuff. I mean, one of the things I always, you look at special relativity, right? The idea that all inertial frames, have the same physics in it, right? Inertial frames, and that everybody has to see light at the same speed. If you start putting inertial frames on all moving things, and this is very much, I look at it as what I call Borchardt infinite universe. I start putting frames on everything. I put a frame on the electron. I put a frame on, so every piece of everything going to have a different clock. And when people try to bend their brains around these kind of weird things, like the universe started from a pin. I don't know what you said now, a speck of dust.
Pinhead.
right. And it's 13. Yeah, I think today they said 13.78. But I have a new app on my phone that like the weather changes every day. It gives me the age of the universe. Hey, that would be a good app. I bet that would be really fun. I'll have to.
We need a web page, George. You could put it up of the ages of these elderly galaxies, how long they took to form. And I was thinking of doing the same thing, where you could have, it starts out like at 500 or something, and now we're down to, what do you say? We're getting closer to
they've got something, they're saying maybe as young as 20 million years after the Big Bang.
Yeah. See, that could be a website, and we can just have it clockwise, and eventually it
10
gets
million,
to 0.
5 million, 1 million.
And then it'll be minus.
Something when you're talking about Einstein and the gravitational waves, originally he was totally opposed to the idea of gravitational waves. Then, as he's done in so many areas, then he changed his mind and said, well, I guess now I support gravitational waves.
Yeah.
He changed his mind on so many things. It's unbelievable. You see how many,
as I've written,
no to yes to no. He's all over the board. So he's always right, because you can always find he was either
See, it's a matter
all the time.
There's two parts to science. One is the data, empirical data. We don't argue about redshift or anything, but the cause of redshift we can argue about.
Absolutely.
The interpretation we can argue about. And remember, the gravitational wave thing proves Einstein's right again. All it proves was that a couple things in outer space banged together, produced a shock wave. That's what it was, a shock wave. That's all it is. It's like if you were standing out someplace and watching fireworks, all of a sudden it was a big enough fireworks or dynamite, it would cause you to undergo a shock too. So that's all that is.
And the fact that shock wave occurs shows that there's no such thing as absolute empty space.
Right. That's the point.
If it's totally void, then there's not going to be any shock wave.
Yeah. And that's why they talk about the compression and decompression of perfectly empty space, or space-time, or whatever you want to call it, which is nonsense.
Absolute nonsense.
It's amazing. You guys, I made this about the Big Bang, and we're talking about Einstein all the time. What's going on? Jeez.
They're all linked.
Stay topic. In fact, I'm going to get rid of Nick. Nick, I mean,
I have to go. I got to
Okay.
write my paper on dark time. Sorry.
Oh,
Bye.
gee. I'm leaving. I'm getting him out of here. I swear, people in the chat, that's what they're talking about now is dark time. That's amazing. I think the other thing that is one of the things I'm really interested in and been over the years is these political and social aspect of bad theories and bad assumptions. And one of the great things about it is that when you are in class, right, you're a freshman in any university anywhere on the planet, and you get taught special relativity, you either look at it and you say, this is nuts. How come when I go close to the speed of light, mass increases? This is nuts. Then another person says, I don't care. This is crazy. I don't care what it is. Let me just do my homework and get my A and go on. And then there's another third that sit there and they can repeat it. And the thing is when you sit there with a group of people in universities who the only way they get in is to agree to their secret laws of the universe, which are illogical, and you have to, brainwash yourself into saying that these things make sense. And that then when you spout your explanations off to class and you have people in the class, or you have anybody outside, you just say, look, you just don't understand it. One of the things was about the LIGO and the gravitational waves. There were two physicists from Denmark who looked at the data from it and said, this is noise. Everything we have mathematically says this is noise. And what happened was for the next 2 years, the people who were involved with the experiment went to Denmark and met and had those people come, and they went there not to listen to them and have a critical thinking and say, oh, maybe you're right. Maybe we haven't detected anything. What they did was they, from the LIGO experiment, spent 2 years trying to convince them of their logic, that they didn't understand what they were doing and what they were saying. And that's what happens in universities. If you go and say the Big Bang's wrong in a classroom in a university, they're just going to say, do you have a degree in cosmology? No. Oh, then what are you talking about? And I say, why don't you get a degree in cosmology? And my answer is always, I can't. What do you mean can't? Because if I did, I'd write a paper and give lots of evidence against the Big Bang. Would they allow me to do that? No. So I said, there you go. And so what you have is a system that's illogical. And this is something I repeated, but many people probably haven't heard it. When I was a kid in grammar school, in elementary school, someone came up to me at one time. I must have been 7, 8, 9 years old. And a group of kids came up. This whole thing only works with a group. And the group of kids came up, and kind of the bully guy goes, "Hey, Dave, how you doing? I got a joke for you." I go, "Oh, okay." And you're a kid. And you go, "I want to know the joke." He goes, 2 polar bears there's a slide, and there's 2 polar bears. The first polar bear goes down the slide, and he goes, "Wee!" And then the second polar bear goes down the slide, and he goes, "Wee! I'm a radio." And then they look at you, get it? And I'm thinking to myself, no, I don't get it. And they get, come on, you get it? And everybody's putting this pressure on you, right? And finally you go, yeah, I get it. And I laugh, and everybody goes, ha, ha, ha. There was nothing to get. And that's kind of the way science is. Science at universities are that way. They put this social pressure on you so that you can't come up to them and say the Big Bang's wrong. Have you been there? Oh, you've got to be indoctrinated into it. So the idea of that peer pressure, they pressure into something. Hey, yeah, it's wrong. I mean, that's one of the things I think that keeps perpetuating this, is because the illogical part of it is something that you can feign is your stupidity in not understanding. I think that's one of the problems.
Can you imagine if you're trying to do a PhD on your thesis on the Big Bang is nonsense? Are you going to get any advisor to take you on?
Well, yeah. Well, I'll give you an example of that, Dr.
How are you going to get it? There's not a single advisor at any university that's going to.
Well, that's why we all know about the Stephen Crothers who who was talking about black holes and how ridiculous at least their model was, right?
Yeah.
And he tried to get into the university. I can't remember where, in Australia or
That's Australia. Yeah.
And he was drummed out. He was
That's
just
right.
literally drummed out.
You've written about him.
Yeah, Dr. Karazani had two students. Dr. Karazani had this experiment to show special relativity wrong, but also the neutrino didn't exist. And well, we've actually found an experiment that already did that. But he said, yeah, there's this experiment you can show special relativity wrong. So he had two grad students from pretty prestigious universities. I can't remember if it's like CMU or something like that. And they went, these two students who had known Karazani, he talked to them about it, and he says, for their master's degree, he says, yeah, I found the experiment I want to do. And they say, both of them, they said to the professor, oh, what? The professor asked what it is. And he says, well, it's going to show special relativity wrong. The professors, both of them from different universities, get up, close the door, says, sit down, sit in front of my desk. And he goes, do you want a degree in physics? And he goes, yes. He says, don't do this experiment. Who else was it? It was Dr. Cynthia Whitney. She did her thesis. She's got a degree in special relativity from MIT, and the first thing she did when she got out of college was to apply it to a ring gyroscope. What's a ring gyroscope? It's the Sagnac effect, and it failed. So she goes back to. I asked her, "What did you do?" I goes, "Well, I'm back to my professor." And I said, "Look, I got my PhD in this. This stuff doesn't work." And the professor goes, we know. He says, well, what are you going to do about it? He says, no, you can't do anything about it. You know, and people don't believe this because the guy on the street basically is going along in this oblivious world going, oh, hey, they saw that the Webb telescope's showing them galaxies that are really, really mature. Oh, the Big Bang must be a lot, you know, the universe must be older, right? No. Oh, well, they'll say it to me. I've had them say it to my face because whenever they talk about what do you do, and I made an Einstein wrong film, they get all into this and they get all into these arguments. And I said, okay, what happens when you have the? Oh my gosh, I lost my train of thought. I was talking about what the big. Okay, senior moment, 62. I forget. But anyways, it was a good story. Oh yeah, I remember. And they go, this is what happens. You've got contrary data out there, right? You've got contrary data as to what the universe says or what our theory says. And I said, well, let's I'm having trouble connecting. And stop that, turn that off. But basically they said, okay, yeah, you can have something come up. Oh, well, what happens when I asked the person on the street? Says, well, what if you have some evidence that like this one person did that Einstein's equations don't work. They fall apart when you put them in a ring gyroscope, when they go around, light goes around a circle. Well, they must go back to the university and take that data with them. And when they see it's wrong, they got to think, oh my gosh, our theories are wrong. We're going to have to throw that out. And I said, have they thrown out Einstein's theory? Because this was back in 1970, this happens. No. So do you think that truly that universities and their scientists actually look at contrary data and that they actually modify current their theories or throw them out? People really do think that. And I think that's part of the problem too. There's nobody out there. There are people who go and I had a discussion with Dr. Alexander Unsker, and he basically, he said something which I agree with. He says the people who go into theoretical physics and cosmology are not the brightest people in physics and cosmology, because the brightest physicists stay away from this stuff. When I asked the experimental physicist, Kelsey, I believe his name, Dr. Kelsey from Slack, in my movie, I said wrong. I said, so before we got to the part of the shoot where my mom's talking about with him, I said, so what's it like to be a theoretical physicist? And he goes, don't ever accuse me of being a theoretical physicist. and so if you look at most physicists, people don't understand that 99.9% of physicists don't believe in this stuff. We have a very small people. It's like politicians. We have a very small group of people who are against doing things for the average person. They all been captured by big money and big, and they do what the rich want. That's basically, we know that. We live in an oligarchy. so we live in a place where we think we're in democracy. We're not. We think we have scientific and critical thinking going on in universities. We don't. Hey, I see Steve Bryant. You were there. Did you want to come on at all? I know. Did you want to come on and say a few things? Okay. Steve is an elegant. Great to see you. We actually have 4 neo-mechanical Borchardt infinity people all together.
Steven, good to see you.
And Steve, how you doing?
Hey,
And also, I want to hear about you're not deciding to do a PhD at Berkeley for some reason. What was that reason?
No, well, first off, George and Glenn, great talk and great to see you both. I mean,
Great to see you, Stephen, my good friend.
I know we've had a
Same
chance
here.
to connect up on typing and things like that. And David, of course, always good to see you as well. I just wanted to first off just acknowledge the work that Glenn and George did. I think they've been approaching this from a very thoughtful place for a long time. And I think one of the things that I wanted to just comment on was building on what David just shared, right? Which is that thoughts and thoughtful kind of analytical approaches, they don't require necessarily a degree. They don't require a PhD. They don't require discipline in a certain field. What it does require is a body of knowledge and mastery of that domain, right? So you do need to know what you're talking about. And a lot of people can get that body of knowledge through a lot of different means and a lot of different ways. What I think is challenging is when someone who has not gone through the same type of program or process that someone else has gone through. So specifically, if someone is going to challenge something like cosmology or special relativity, and that someone does not have that PhD in that field, then it becomes political. And as David was mentioning, it's hard for someone who's going to have that contrarian perspective to be recognized in that field, either through a PhD or through publications of their work. And I think that becomes one of the challenges. I don't think it's necessarily an artifact of inferior work or an inferior analysis. In fact, I think it's easy to show that in many cases that's not the case. But as David mentioned, and as Glenn and I think George would attest to, right, there's a lot of money at stake. And in fact, I'd say there's a lot of wealth, and I'll generalize wealth to be both material and non-material wealth, right? Because you have ego involved, you have reputation involved, you have money involved. And there is an idea, something that I call, well, I don't call it, there's an idea out there in computing called zero-day defect analysis. And when you look in computing, one of the things that you do in zero-day defect analysis is you recognize the solution works, the solution is deployed, the solution is giving great answers until someone finds that zero-day defect, which says, except in this edge case, it now fails. Except in this edge case, I can now exploit it. And we have that same type of problem in some of the theories where it gives useful answers. But useful answers, and I don't know if this was George who mentioned it or Glenn, but useful answers doesn't necessarily mean the only answer, right? And so as soon as we recognize that there are other possibilities, then we can have a broader conversation and say, yes, 22 divided by 7 is 3.14, and it's useful for certain things if you're in 8th grade math. But it's not useful if you're trying to land a spacecraft on Mars, where you really need to use pi to probably more significant digits than that. So we need to look back at what we're doing, whether it's cosmology, whether it's Big Bang, whether it's relativity, and recognize a couple of things. A, some of the analysis that multiple people are bringing should be considered, and should be considered thoughtfully, instead of just automatically rejected under the idea of, this has been looked at 1,000 times before, it's been proven, when in reality, like I mentioned for zero-day defects, the absence of a defect does not mean that it is defect-free. It just means that the defect hasn't been identified yet.
Remember that the person who challenges a paradigm has to be outside that paradigm. You can't have a conflict of interest. You can't be paid. If you're a paid theoretical physicist, it's not going to happen. And so that's why we have this wonderful opportunity, not being paid theoretical physicists or cosmogonists, to actually experience this over the next 30 years. Wish I could live that long. Next 30 years will be the time of the debate over the Big Bang Theory. And us guys who are on the outside, and gals, we want more gals, of course, to challenge the Big Bang Theory and get rid of it. It's a blight on humanity. To think that we ever thought the universe exploded out of nothing is ridiculous, absurd. And we need to, and it's lucky that we are lucky to be in this position because we are qualified. We are qualified because what? We have the 10 assumptions of science and we are outside the field and we can take down the Big Bang. It's just going to take a long time convincing a lot of people.
You know, something interesting when they talk about if someone challenges anything in science, and if they don't have a PhD in that specific area, they're dismissed. But you take someone like Halton C. Hart, who was the most qualified person. You're all familiar with Halton C. Hart. When he came up showing that these quasars were nowhere near as far away as what were supposed to be, the people that he's showing them to within the astronomical community, they're just saying, well, we don't want to look at them because we know the pictures must be wrong because we know that these quasars are like 10 billion, 5 billion light years away. And they basically, he got punished by losing his telescope time at Palomar. He had to go to Europe. I mean, take another example, like David Bohm, when he came up challenging the interpretations at that time, the standard model of quantum mechanics, the Copenhagen interpretation, the word was put out by Oppenheimer, just ignore his paper.
You are muted for some reason. You muted yourself there. That's okay. While he unmutes himself. Okay.
There you go. You're back.
There you go. You're back.
And with David Bohm, he had written the textbooks on quantum mechanics, but when he moved away a bit from it with his quantum theory, the scientists at the time who were like Oppenheimer said, just ignore his paper because we can't dispute him, so just ignore him. So it doesn't matter whether you're totally within a field and have got the best training and the best PhD universe, you'll be ignored. And if you don't have gone through there, you're told, well, you don't have the qualifications to challenge this. So who is allowed to challenge anything anymore in science then?
Well, George, what that proves is that the challenge that you have to do that in order to move science forward is false, because they have shown that. So what they put up there is you've got to get a degree, and then when you get a degree, and then you go against them, then what you said, wait a minute, I thought you had to get a degree. Oh, then they're going to have to qualify by saying, oh, you don't have to you not only have to get a degree, you got to agree with what we're saying,
or you'll be ostracized.
That's the truth.
You get ostracized.
That's what, and they are like, just like the student who wants to be, they can get into and become a theoretical physicist by repeating what other people repeat. They'll repeat the explanations, and they'll say, you don't understand. I have a degree in physics and I don't. When I was I was making the movie and I was shooting at Poly High in Long Beach, the advanced physics class, some of these kids were going into Harvey Mudd, other places that were very advanced. I asked the kids, 50% of them said they would forego truth in order to get their position. 50%. And in my movie also, there was an anonymous survey done by the University of Michigan, which asked scientists anonymously, have they ever changed the data to fit their conclusions? 1/3 admitted that. So whenever you see anything, being a critical thinker, you're seeing that more and more. I think part of this breakdown that Glenn is talking about is happening at the societal level. So Hussein has weapons of mass destruction. Oh, the Russians hacked us, and we're finding out all these things are not true. People are starting to go, we're being told all kinds of things, but are they true? People are more and more questioning, and I'm hoping that kind of direction is going to.
The sad thing about the Big Bang is that it denigrates all of science. It makes us a laughing stock and will in the next decades. It just is. And and you're going to look back on that, and all of a sudden, Einstein, who's Einstein? I never heard of him anymore. That's what we're going to hear in 30 years. And that's how it's going to work. But right now, the skepticism that people have about science, no wonder. You're talking about the universe exploding out of nothing. Come on. We don't believe anything that you guys say. I don't care if you got a degree or not. I mean, any difference.
Yeah, I have this saying that the engineers and the physicists who are real physicists, I have this saying, what they say, "Oh, wake me up when you have something real." And that's what I think a lot of people do. The people who are real critical thinkers, they look at this stuff and they say, we're lost. I mean, I've said many times, if there were such things as more intelligent beings coming to this planet, I'd be embarrassed by the state of physics in Mount. I'd be embarrassed. I'd say, I apologize. The human race is really lost. And so what you read in Wikipedia, this is sad, but it's true. I mean,
so I want to say a few things, David, building on what you just said and what Glenn just said, and also looking at some of the comments. Number one is that it's not a hardline divide where on one side of the fence are all physicists with PhDs and on the other side is anyone who's critical. In fact, some of the people are on both sides are somewhat welcoming. I know PhDs in physics who've read my work and provided just excellent feedback. I also know people without PhDs in anything who have also given me just excellent feedback and work, and vice versa. So I don't want to make it an all or none proposition. The other thing I do recognize is that to some extent, we as a society have to hold on to certain ideas. Just the way humans behave, we have to have things that we generalize. So whether they're theories or beliefs or ideas, biases, and I'm not saying all of them are good, but they help us operate as individuals and they help us operate as a collective. And so having a theory that seems to work and seems to provide good answers, and having people say that and repeat that becomes one of those things that people can latch onto, and it becomes useful. The challenge is when we do not allow a conversation around that any further. So we will hear all theories are fallible, right? People will say that. They'll stand behind it. They'll say that about Einstein. But as soon as you raise your hand and you say, let's have a discussion about that, or the Big Bang, let's have a discussion about that, you get name called, your qualifications are questioned, you're summarily dismissed from peer review process. I would challenge those, I'll call them gatekeepers, right? So the peers of the PhD programs, the deciders of what gets published or gets peer reviewed, to actually allow some of these to come through. And if they don't rise to the standard, we're in the digital age today where you have places like Facebook and Twitter and all sorts of chat rooms. If you put a work out there that is really silly, the world will comment on it and it will quickly be regarded as such in the comments, and it will fall into oblivion. So I think we are at a point in society where these gatekeepers, if they really want to help advance science, going back to what you just said, David, we can now have a discussion about these things. And to what Glenn was saying, that type of discussion has the opportunity to elevate science by saying, we can withstand these questions. We can withstand this type of discord, and we will survive. And so that's one option. if it doesn't survive, if that theory doesn't survive, then science is still in an advantageous position to say, we adapted, we changed, we reflected what is, in this case, different and a better model. All I think we need in terms of whether you're a contrarian of science or I shouldn't say of science, of a theory, contrarian of a theory or proponent of a theory, is just professional discord. And that is where right now the professional gatekeepers are preventing that type of discord from happening. And unfortunately, it's right at that barrier where we start to have the conflict and the name calling and the politics and all the other things that we're seeing.
Yeah, I'm going to move forward here. We got Steve. If you haven't read his book, Stephen Bryant, Disruptive, Rewriting the Rules of Physics, check it out. It's really great. We also had, I think we've interviewed here at least one time. And so check out his work. I thank you very much. I'm going to bring somebody else up. Thank you so much, Steve. It's great to see you.
Stephen.
Likewise.
Yeah, same here.
Okay, so I know James Keene's been sitting here and he's been keen to come in. So we are here. We got 10 minutes left. I wanted to bring you on with very little time so I could easily cut you off.
Oh, okay, that's good.
Just kidding. I'm kidding. My bad.
I'd like to be a little bit of a maverick here. None of the participants today have addressed what I consider to be perhaps the fundamental problem. We can view the participants today and others as sort of students trying to learn calculus and having problems in learning calculus. And we try different approaches to see if we can understand what the problem is in this learning process to solve it. And we suddenly discover they haven't mastered algebra yet. Now, we've talked a lot about certain causes. The Big Bang theory is no good, and relativity is no good, and so forth. But the fundamental question keeps being skirted, and that is, we haven't yet a single theory, except binary mechanics, of course, of why the speed of light in vacuum is what it's measured to be in over 100 years. So the so-called fundamental constants, that's actually a doctrine, almost a religious belief. Actually, they're unexplained observations, okay? And one would think that, well, we can't get to the calculus of Big Bang and the universe, is it infinite, and all of these questions until we master some of the basics in science. For example, other fundamental constants like Planck's constant, the elementary charge of the electron in coulombs. Why do they have the values that they have? It's been, in my opinion, a scandal that we're going to consider these as universal fundamental constants and simply ignore the fact, yet we try to explain everything else. Everything is on the table for scientific investigation, except explaining why the vacuum speed of light is the measured value that it is. And so I'm a little bit surprised that none of the participants today have really pointed out this scandal, that we can't get to calculus without first mastering some algebra. We can't get to algebra unless we know some arithmetic. And I think that the participants today might do well to just sort of step back and say, we have some fundamental unexplained observations and lack of theory or an idea of why they have the values that they have, and not say 10 or 100x bigger or smaller. So that's my critique of today's session of what's been missing. And as long as that is missing, I think we're going to have sessions like today that go for an hour and a half or more without getting really any conclusion at all, except that certain of the theories based upon pure, fantasy are questionable. So that's my comment. If any of the panelists wish to reply or comment on that back, I would appreciate that. But in other words, I think all this discussion about Big Bang and is relativity right or wrong and so forth is really premature. I think we have to master arithmetic first to make science and physics as a science progress. And until someone can tell us why the speed of light, excuse me, why the speed of light is the value that it's measured to be, and other of the so-called fundamental constants, which is actually a doctrine. These are unexplained observations, and now I'm repeating myself. So I will rest my case and wait for any comments, if any, on my maverick opinion here. Thank you.
Okay, yeah, I can address some of them. First of all, Glenn actually did say during this talk about, for instance, the speed of light coming from the properties of a medium. Okay, and also the speed of light in other models, including my father and I have a model, have an explanation. It's a different explanation, but it talks about it. Second, another thing is the constancy.
So you can actually determine why the speed of light is what it's measured to be.
If you want to,
or is it just some ideas of why it might have that value?
Well, I think the whole idea of coming up.
I'd like to see that. That would be a proof.
Well, there's no proof, but there's never proof for anything. Well, there's never. But we did. But what I'm saying, James, what we're saying, James, is that we don't believe there are proofs. The two things that I see that are, you can have something support a theory, an idea, or a model, or you can be just less wrong than someone else, as my father puts it, which I think is more of an engineering look at the world. So
okay, this is philosophy. I'm talking about science. In other words, no one here wants to address the unexplained observation of what the speed of light is. That's sort of like
no, that's not true. Not true. I understand what you're saying, but what you're saying,
we want to
my
explain
argument,
everything else in our environment except that and elementary charge. And
there are
constant is the value.
There are models out there that do describe these things, yes. And so
well, I'd like to know what they are. I think you should have a show
the
on
universal, the infinite universe theory.
I've seen none.
And then also
I've seen no models.
Well, then you got to look around. There's Jeff Yee's model. There's Glenn Borchardt's models. There's my father and I have a model. Those are all physical models, and they're all Newtonian.
Indicate that the speed of light is what it's measured to be. So it's not an unexplained observation anymore. Is that what you're saying?
No, what I'm saying is that I think if you look at even like at the infinite universe, which I am a person that subscribes to that notion, is that the actual speed of light is a kind of you can say that it's a kind, what the actual number is kind of irrelevant. Where it comes from and why it's around and why it's like a constant. Why it's really like a constant. No, I'm talking about the
you're
speed.
Saying that science and physics cannot touch this.
No, I'm saying it can, but the answer you're looking for is why is it
everything in the universe except that.
No, you're saying that why is this the actual number is what you're asking. I'm saying the actual number is irrelevant. Its behavior and what we see is relevant. Yes, it looks to be constant,
and yet
but
all the theories use this value. All the theories that everyone is debunking here.
No, that's not true. Not all the theories, not all the amount. Our model does not use it.
Why the value is what it is.
Our model doesn't use charge. It doesn't use
anti-science group here.
You are making assumptions about what you say is a good model, and we are disagreeing with that. That's what we're saying. I'm sure that because I know.
Well, does everyone else disagree that these unexplained observations are sort of like sacred and taboo and we can't touch them and they're irrelevant?
No, I don't know. First of all, we're not saying they're sacred. We're saying the exact opposite. They're kind of arbitrary because the actual value of what C is an average of something. Yes. That is the universe. We see it, we can measure it, But the idea that this is some, sacred thing, it isn't a sacred thing. It happens to be a behavior that seems to be a result of either there's ether there or there's particles with smaller particles
Well,
hitting
why
them
do we
below.
spend so much time on relativity and the Big Bang when we can't even explain the measurement
Because our
of speed
idea
of light?
is here, and being critical
I mean,
thinkers is our
it's
idea
like we're
for
trying to do calculus and we haven't mastered
you
algebra
said that
yet.
before. I understand that you said that. You said that. What we are trying to say is that the model for the models in current science and cosmology are wrong, and they are wrong in so many senses. There are better models out there. That's all we're saying. We're not
Well,
out
that's
there.
fine.
That's what
But
we're
I'm
talking about today.
raising the question: if these things are wrong, how come none of the participants, Ian, Nick, Harry, and our wonderful panelists who did a great job, thank you, George and Glenn, none of them have addressed this fundamental issue?
Because we don't see that. We see that issue very different from
Dave
you.
speaks
That's
for
why.
everybody. My
No.
God, yeah, everyone is mute. Okay.
I know what Glenn and George, we've talked about. I've talked hours and hours with them about it. What we are talking today, the speed of light yes, it's intimately linked with the problem with the Big Bang. And Glenn spoke about that in the beginning, didn't you, Glenn?
Yeah. So
I mean, he spent like the first 10 minutes here talking about how the speed of light gets us into trouble because we think that's
not an explanation of, yes, Glenn did that, but that's not an explanation of why it has the measure.
Right, but that's a different subject for a different time.
Yeah. And Jim, let me ask you this
like
question.
You put something on a scale and
of,
you measure so many kilograms, why does it have that weight?
Jim,
hold on. Let Glenn talk. We've got your point. You're repeating yourself. Okay, we got it.
Why is the speed of sound what it is? Jim, it's 343 meters per second in atmosphere at sea level and temperature 25 degrees centigrade. Okay, why? And do we care? I don't really care. I just know it's 343. That's fine.
Right. Yeah.
That's all I need to know.
Well, you just accept the
no, it's not accepting, it's measuring it. You're saying we got to measure it.
The values.
We're measuring it.
You have to tell me why it's 343 in atmosphere.
Amazing.
Do you have a theory for that, a calculation?
He's asking the question in sound. It's the same thing.
Maybe knowing 343 is fine.
Right. Knowing the speed of light is this value in general, that's very important, yes. But because it's 300,000 or 299,998 meters a second is not, it's arbitrary. We put a number on it because we made a meter. Why is this a meter? You go to some other civilization, it's going to be a different number. So
okay.
And that's because the universe is infinite.
I just thought that this group was interested in science. That's all.
Yeah,
we are. But that kind of accusation, I think most people would disagree with you. But I appreciate you coming on and making your points because that's what we're about. So we got to get going because we are past our time. So thank you very much, James. But I do want to thank you, Glenn and George, for coming on, especially being so early for you guys. I thought this was just really wonderful time to talk about it. But we have all kinds of other things that we can talk about in the future, like this one, the disco ball science satellite that will prove Einstein's theory to the strictest test yet. So if any of you guys think we don't have more to discuss, we do. But I do want to thank you first of all for both of your works. I will put them up here one more time. Here's Glenn's books here. You can go on and look him up on Amazon, and you'll see his books. I recommend all of them, any of them. They're all great. The Scientific Worldview is an opus, really, in my opinion. The 10 Assumptions of Science, I believe, are part of that book as well. Any of these books, I think, are really great. We also have the book by George Coyne, and I just love this book. And of course, yes, we do all subscribe to very similar ideas. I mean, my dad and I's model is built on top, literally pushing Glenn Borchardt to the ground with our weight on top of him. How much we use his model of the infinite universe. So and then so does George. And again, we all work in that area. It's not because of that, but because George specifically, if you're interested in the Big Bang, besides Glenn's work, has a lot of work that specifically addresses the Big Bang. There are 64. It's a little disappointing it's 64, not 65, but we'll live with that. But I highly, highly recommend that you look into these books. And I want to thank both of you. And hopefully we'll have you guys back. If you're glutton for punishment to get up at 7 a.m. to talk here, I think, we have many, many more things to talk about. But thank you so much.
Thank you, David.
Yeah. Thanks, David. Now we can go back to sleep.
I got to go to work. I got 8 hours ahead of me now.
Yeah, listen, thank you so much. Listen, I just want to really thank all of our the people in here, including James for coming in and confronting us with his ideas as well. Stephen Bryant, check out his work. Ian, who's always about, and I do want to thank everybody also in the chat. I did see great things going on, and I do see people are enjoying this, and we do. In fact, I do know that people do watch these afterwards. We got Tao Lin, one of the up and coming great writers of our generation, who lives in Hawaii, who can't get and watch this at the time. He always watches them while he's drawing his mandalas. So shout out to him and everybody else who watches this, and to all the subscribers. And make sure you do push the subscribe button and you push the like button. It's very important, because that's the way you can support, and more and more people can see great things like this, like our show here, because there's nothing like this on the internet. And I do want to, and remember, you can go to naturalphilosophy.org and let's see, dissidentscience.com. Both of those, you can go to those YouTube channels to check us out and subscribe. But we also you can go to naturalphilosophy.org. Where is that here? I've got it somewhere. Shoot, I don't have it, but go to naturalphilosophy.org and you can go there and become a member of our organization. And please think about donating. We do have $2,800, I think, per year for all of these things that you see, our websites, our server, all those kinds of things. They do cost money. None of us obviously make money from this. So please do consider that. And well, we're going to get ourselves on the way out, as we normally do here. Remember what I always say, stay critical, stay thinking. I'm Dave D. Hilscher, your science therapist, trying to get you to the promised land of becoming a critical thinker. Ciao for now.